What we're going to do today is collect data for the observation and the scientific method lab. The first thing that you need to understand is what is the purpose of this lab. So in part A, we're going to mix calcium chloride, sodium bicarbonate, and bromothymol blue together and observe the changes that occur. In part B, we need to perform controlled experiments to then determine mixing what substances together cause the changes in part A. So the next thing that we need to look at is what are the materials that are used for this lab. So you need bromothymol blue, calcium chloride, sodium bicarbonate, water, graduated cylinders, measuring spoons, and plastic bags. The first data that you need to collect is this portion right here, and that is where you're going to make observations about what these starting materials look like before they are mixed together. So calcium chloride looks something like this, the image that's on the left-hand side. It's these white solid chunks. Bromothymol blue is a bluish green liquid. It is made up of bromothymol blue powder that is mixed in water. Sodium bicarbonate is a white solid powder. All right, now we need to go over the overall reaction, how we're going to perform that. So inside of a Ziploc bag, what we're going to do in the lower left-hand corner, we're going to add 1 teaspoon of calcium chloride. Then in the lower right-hand corner, we're going to add a ½ teaspoon of sodium bicarbonate. Then we're going to measure out 5 milliliters of bromothymol blue in a graduated cylinder and place that kind of towards the top of the bag. We need to carefully seal that bag, and we should have something that looks like this. Then what we need to do is we're going to mix that bag together, all the materials that are in it, and observe the changes that occur. So the 3 observations that we want to make: what happened to the temperature, what happened to the color, and also what happened to state as well. Was there a change in state? So here is what the reaction looks like when those 3 things are mixed together. So the first thing we're starting to see is that there's a color change. You could see that that bluish green bromothymol blue starts to turn a yellow color. You also hear a fizzing and the bag is starting to fill up. What that tells us is that a gas is being formed. The one other thing is that when you touch the bag and you feel the reaction, it feels warm to the touch. So there was a color change, it went from greenish blue to yellow. There was a temperature change, it got warm, and a gas was produced. So in this table, in part 2, you need to record those observations about the changes in the color, the state, and the temperature. The next thing that you need to do is, based off those observations, you need to write 3 questions you would like to investigate based on your observation. So now we've completed part A. Those 3 substances were mixed together. We observed a change in the color, a change in the state, and a change in the temperature. Now what we need to do is part B. What we're going to do in part B is perform different controlled experiments where we're going to try to figure out what specifically was causing the changes to occur in part A. So the 4 variables that we're going to look at: 1 teaspoon of calcium chloride, ½ teaspoon of sodium bicarbonate, 5 milliliters of bromothymol blue, and another 4th variable that we need to consider is 5 milliliters of water. Bromothymol blue is a mixture of the bromothymol powder and water mixed together, so we need to test, in some of these cases, water by itself to see whether or not it was the bromothymol blue that was causing a change to occur or the water itself. In all of these controlled experiments, we're always going to use the same consistent measurements. Always 1 teaspoon of calcium chloride if it's being used, always 1/2 teaspoon of sodium bicarbonate, always 5 milliliters of bromothymol blue, and we'll always use 5 milliliters of water. So first thing is, here is your data table for part B, the controlled experiments. For each trial, you need to make a note of what was being mixed, so you can put a check mark or like an X in the box. Then in the observation side, you need to write down any changes that occurred in terms of state, color, or temperature. In some of these trials, nothing is going to happen. If nothing happens, write down no changes. Seeing that nothing happened is just as important as seeing that a change occurred. So in trial 1, we are going to mix the two solids together, calcium chloride and sodium bicarbonate. So in the plastic bag, we're going to mix those two things together. And what we are going to observe when we mix them together is that no change occurred. So when the two solids were mixed together, nothing happened. All right, next is trial 2. In trial 2, we mix calcium chloride, sodium bicarbonate, and water. So we're just going to use water. We're not going to use the dye. This will allow us to see whether or not it was the water that was causing a certain change to occur, or was it the dye. So when those three things are mixed together, what I end up observing is that the reaction feels warm, it's hot, and I also see that there is fizzing occurring that tells me that a gas is being produced. So in this trial, a gas was produced and the temperature became warm. In trial 3, we're going to mix calcium chloride and dye together. So when we mix those two things together, what I'm going to observe is that the reaction feels warm. So the one observation I'm going to make is that when those two things are mixed together, it feels really hot, it feels really warm. Next trial, trial 4, I'm going to mix calcium chloride and water together. And when I mix those two things together, I once again feel that the reaction is warm. It feels really hot to the touch. So the one observation I'm going to make is that there is a temperature change. It became warm when those two things were mixed together. In trial 5, we're going to mix together sodium bicarbonate and dye. And when those two things are mixed together, the reaction is going to feel cold. So my observed change is that it becomes cold. For trial 6, we're going to mix together sodium bicarbonate and water. And for this reaction right here, when those two things are mixed, this also feels cool to the touch. It became cold. In trial 7, when we mix together dye and water, what's going to happen is no change is going to occur. In trial 8, we're going to mix together calcium chloride, dye, and water. And what we end up observing for that one is that the solution becomes really warm. So our observed change is that it becomes hot, it becomes warm. Finally, in our last trial, we are going to mix together sodium bicarbonate, dye, and water. And what we're going to end up feeling is that it feels cool. So I know I didn't do the best job with recording that one, but when those three things are mixed together, it feels cool to the touch. All right, so let's summarize what we did today. In part A, we mixed calcium chloride, sodium bicarbonate, and bromothymol blue solution together. We observed that the temperature became warm. We observed that a gas was formed and that the color went from a greenish blue to a yellow color. In part B, what we did was a series of 9 different controlled experiments where we mixed different variables from that part A in order to figure out what specifically was causing the changes to occur in that first part. What you should have accomplished at this point is you should have the data collected from part A and from part B.